All right. Good morning, everyone. Welcome. We're going to give everyone just a minute to join, and then we will go ahead and get started today. So, got quite a few people in the waiting room, so we're going to give everyone a chance to get into the meeting. All right, still a few people filtering in. We will go ahead and get started this morning again. Welcome. Thank you for joining us on this Thursday morning for this extended session today, where we will be sharing results from our March 2026 temperature update, as we normally do every month. We have also added a fairly extensive review of our analysis of the March heat wave in the Western US, as there were a number of rather exceptional findings from that analysis. So we're excited to share that with you today. And we will go ahead and get started with some quick introductions as we usually do, and then I'll pass to Robert to give the presentation. So if we want to do next slide. So just a quick introduction to Berkeley Earth for those of you who may not be familiar with us. I know I see a lot of familiar names in the session already, so I know most of you are already friendly with us. But just a quick intro for those who aren't. Berkeley Earth is an independent 501c3 nonprofit climate monitoring organization. We produce a number of data products in order to help provide high resolution local insights into climate change. Our mission is to make independent climate data accessible, transparent, and actionable. Joining me on the call today, I'm Kristen Sissener, Executive Director of Berkeley Earth. We're joined today by Robert Rohde, our Chief Scientist. Beak Housefather, who is usually with us, is traveling this week and wasn't able to make this call, so we will miss him this month, but hopefully he'll be back with us again next time. And I also want to say thank you for having Kate Viscara here as well, who helps take care of everything behind the scenes and puts this all together for us. So Robert had preempted with the next slide. The analysis graphics that you're going to see in today's presentation are all made using Berkeley Earth's own observational temperature record. This is our core product. Our high resolution product, we provide quarter degree by quarter degree spatial resolution. Uh, we have subsets available for more than 8,000 global cities available off the shelf. We can also provide custom subsets of locations on demand. We also provide Tmin, Tmax on a regular monthly cadence as well. This is licensed under a Creative Commons non-commercial license, but we do offer commercial licenses as well for those who are interested in using this in their own work. Just a couple quick housekeeping notes. As usual, we do record this call, so it will be available. We will send it out via email probably early next week once we have everything, all the reports generated. The March temperature update will be available at the end of the presentation, and we will have a QR code available for that. And we will be taking questions as usual as well. So once the presentation is over, we will start going through those. Feel free to pop your questions in the Q&A box during the presentation, and then we will start taking those once we're done. So with that, as we have a pretty extensive presentation today, I will go ahead and pass to Robert to get started.
Well, hello everyone. So we're going to start by looking at global temperatures at March, and then we're going to have a substantial digression on what happened with the heat wave in the US in March. So to begin, global mean temperature in March 2026 was the fourth warmest since 1850, behind 2025, 2024, and 2016, slightly ahead of 2023 and 2017. Though given the uncertainties here, it sort of overlaps anywhere from first to sixth. These are all sort of tightly grouped together. We find it was 1.45 plus minus 0.11 Celsius above the 1850 to 1900 average, so a bit less than 1.5, but still much warmer than any March prior to 2016, as you can see the long-term warming trends here. In terms of month-to-month variation, March was similar to February, very small tick down, uh, but behind most of the months in 2023 and 2024. So we're still in a slightly cooler state. We are closer to the long-term average in this recent couple months. And here is the similar, different way of looking at the same data, looking at each year wrapped across the screen. And the present trend for 2026 is a bit behind 2024 and 2025, though still among the warmest years that have ever been measured. Okay, March 2026 had some interesting spatial structure to it. We had widespread warmth across most of the world compared to the middle of the 20th century, which is what we expect to see most of the time from global warming. There's particularly excessive warmth across the United States, Northern Europe, many parts of Asia, some Antarctica, and also significant warm spots in the northern part of the Atlantic and parts of the Pacific Ocean. Uh, it was unusually cold in northern Canada, though only a small portion of that is record cold, as I will talk about in a moment. 5.6% of the Earth's surface was locally record warm in March. And I will go ahead and mention it because we have this sort of grayed out region on here that's fairly prominent, that we are still having issues with certain NOAA products being delayed or not available. And as a result, certain parts of the map are they they are not available at the moment. Most of this gets infilled after 60 days as other sources provide data, but it means there are some small gaps in the immediate time. Now here is the map of records and near records for warmth and cooling in March. There were significant areas of record warmth, about 5%, 5.6% of the Earth's surface, 4.9% of the land, 6% of the ocean, with significant records across Scandinavia, the United States, and northern Mexico, northeastern Asia, warmth across the Pacific, and as well as both in the northern hemisphere and the southern hemisphere regions of record warmth Pacific, and also a record warm patch in part of the northern Atlantic. And I will note that there is a small area of record cold near the Alaska-Canada border, whereas most of this is near record cold, but there's a small area of record cold up there, which we will talk a little bit more later. I would mention that we are going to get into this a bit in great detail later on, but record March warmth was present in the Western United States. It was 11.6 Fahrenheit, 6.4 Celsius warmer than the mid 20th century average. That's 3.6 Fahrenheit or 2 Celsius higher than the previous record. That's a very large margin to be breaking a monthly average record for an area the size of the Western US. And since the mid 20th century, the March average has warmed about 4 Fahrenheit or 2.2 Celsius in this region. As I mentioned before, there's still some issues with data availability. We like to have our full analysis tends to have about 20,000 stations across the globe. Since last August, there have been delays and disruptions to data distribution originating at NOAA. And that's been causing us with some gaps in our maps and delayed availability. A lot of this gets filled in over time. You will see as you go back in months, the amount of station availability increases, but it is a impactful thing. And we're working to mitigate this by pulling in more real-time data sources and potentially raising funds to do more aggregation independent of NOAA. NOAA has played a leadership role globally in aggregating data, but most of the data originates from national meteorological services in other parts of the world. So it's data that still exists, but we need to have the resources in place to take in data from large parts of the world. Before I go on, I will mention that as a result of delayed data. We had an unusually large revision to the temperatures in February. Our preliminary print for the February average had it as the second warmest. We have since had additional data come in, and it's now moved down to the fourth warmest. It's a, the difference is about, it's a fraction of a degree here. But that is a unusually large revision. What we did, however, print unusually large error bars on our February temperature, which we noted in the previous report. So this happens sometimes when there's delayed data, as there has been in recent months. Okay, breaking down March average temperatures a little bit more. The land average was the sixth warmest, falling below that of recent years and 2016, at about 2 Celsius above the 20th century, above the in pre-industrial. And the land average ticked down from February, is now close to the long-term trend line. But it's still, quite elevated compared to previous months, decades, going back decades. The ocean average was also close to the long-term trend line. It is nominally the second warmest March for the oceans, though with a large uncertainty that incorporates a significant possible range there. 6% of the ocean surface was reported as record warm in March. And it's also month to month, it's very similar to February. We did not see a large change in the global average of the ocean. But we have to note that there is there is a trend upward in recent ocean temperatures from the minimum around La Nina in the La Nina that occurred over the last winter. And we are still well off of the highs that were associated with El Nino in 2023 and 2024. Speaking of El Nino, we have in the Central Pacific, the temperatures have warmed. We have officially left La Nina conditions after dipping back into La Nina for the second time in recent months. So we have been trending quite a bit warmer. It's a significant piece. This region, in the Central Pacific is cool compared to the global ocean, but is not very cool at the moment overall, as therefore moving away from La Nina. We are currently expecting, based on forecasts from from NOAA and the Climate Prediction Center, that the El Nino will develop over the coming months. More than 90% chance that we will have an El Nino before the end of this year, and a substantial risk of a strong or very strong El Nino. So almost 50% chance of a either strong or very strong El Nino event. El Nino is likely to increase global average temperatures in 2026, and it will almost certainly increase global average temperatures in 2027. There tends to be a delay of a few months between the impact of El Nino, between the development of El Nino and its impact on global mean temperature. And as a result, if we had an El Nino that's sort of peaking around this coming winter, the effects of that will be shown up much strongly in 2027 than they do in 2026. But we do want to see how this plays out. Some of the forecasts are calling for a relatively early El Nino development, where we see El Nino taking root in early summer. But we will have to see how that actually plays out and how much impact it has on the temperatures over the rest of the year. Right now, we are estimating a 5% chance that 2026 becomes record warmth, that it's warm enough to eclipse 2024. That is down from what we estimated last month, which was 16%, in part due to the revision of the February temperatures that came down, and in part due to March being less prominently warm. It is more likely that we have a second, third, or fourth place finish somewhere below the top, but in this cluster. And it's less than 1% chance that it's any farther below that, anywhere below uh, fourth place. So we'll probably have 2026 lying somewhere close to the trend line in a sort of second, third, or fourth warmest kind of year. But we will see how it plays out. Strong El Nino will push it towards the high end of that range. A weak or middling El Nino might be sort of the baseline case at the moment, sort of medium. Okay, so I'm going to pivot now and talk in some depth about the heat wave in March in the United States. So this is the temperature anomaly map for one particular day, March 21st, showing widespread temperatures at least 30 Fahrenheit above normal. Uh, I'm going to be liberally mixing Fahrenheit and Celsius, so my apologies to the Europeans and other people in the audience. But yes, this is about 30 Fahrenheit, which I believe is 16 Celsius, somewhere like there, above normal for this particular day, which was one of the more extensive days in the recent heat wave. The scale of this is unprecedented in the measured heat wave, measured temperature history of the US, and it is under standard statistical models. We would say that this is essentially impossible without the effects of climate change raising this up, even though most of the change was due to weather and not climate impacts. So I will explain that what I mean in just a moment. So to zoom out a little bit, here are March temperature anomalies across the North America, essentially. I apologize that there's no label on the color scheme, but the range here is about +9 Celsius to -9 Celsius in the color scheme, which is quite large. And what we see is very extensive warmth across the western United States, extending into the eastern United States, coupled with cooling, but often not record cooling across most large parts of Canada and Alaska. The western US had an average temperature that was 11.6 Fahrenheit, warmer than the mid 20th century average, 6.4 Celsius warmer for the monthly average. That's 2 Celsius, 3.6 Fahrenheit above the previous record. And it's very unusual to see records beaten by that large a margin. This is also the largest deviation from trend in this 170-year record, just slightly beating the deviation in 1910. So this was a big deal. This is sort of a whopper of a heat wave. And when I say that climate change contributed, we note that the mean temperature across this in March across the Western US has risen about 4 Fahrenheit or 2.2 Celsius since the mid 20th century. And without that boost, I don't think you get to a temperature of almost 12 Fahrenheit above normal. You imagine you're sort of getting a 7 or 8 Fahrenheit weather fluctuation and a 4 Fahrenheit deviation due to climate change. And both of those being present is how you get into this stratospheric realm of getting that large an anomaly in March. There's some additional text describing that. So there are about 3,000 active weather stations in the US. More than 1,000 of them set or tied the monthly March records. More than 200 of them were so warm in March 2026 that they equaled or exceeded their existing April record for that location. 10 stations even tied or exceeded their May records for that location. So that's quite an extremely extensive region to be setting monthly records. And by quite unlikely amounts. I'll give a couple examples of stations that were doing fairly extraordinary things in March. Phoenix had 3 days in a row of 105 Fahrenheit, 40 Celsius, beating its previous record by March by 5 degrees Fahrenheit, or almost 3 Celsius, and tying its record for April. So this is far above what we would anticipate for this time of year, and in fact is the largest positive deviation above normal any time in the history of the Phoenix weather station. Another example, this one from Sedan, Kansas. It reached 100 degrees Fahrenheit on March 22nd. That's more than 2 months before the previous reported earliest 100-degree Fahrenheit reading, which occurs out here just at the end of May. Then it's essentially tying the record for May all the way back in March. This is quite extraordinary for a weather station that's been in operation for more than 130 years to be setting records, breaking records that are months before previous. I would note that usually when we see monthly records broken at a weather station with a long duration, it's by a fraction of a degree. We expect to see a couple tenths of a margin. Many stations broke records by 2 or more degrees Fahrenheit, 1 or more degrees Celsius. And in fact, the 1,000+ stations that broke their record in March was the largest fraction of active weather stations to set a new record since the Dust Bowl in 1934. It's the second largest fraction all time. Nothing like this has ever been observed in March of any March since record keeping began. Usually, you have sort of a few percent to sort of up to 10% of weather stations might set a new record in any given March with a large heat wave. This is a third of weather stations setting new records all at once. Looking at average temperatures across the western US, we have this deviation that was, peaked at 23 Fahrenheit, 12.5 Celsius above normal in mid-March. And that's an exceedingly large spike to be getting for a region this size. It's the largest positive excursion on record for this part of the world. And it is, it's lucky in some regards that this happened in March rather than happening in summer. People may recall the heat wave in the Pacific Northwest when Canada set all-time records at Lytton. That had a very similar kind of excursion to what we're seeing here, except it happened in summer instead of in the spring. Because it's spring, the impacts on human health are much more muted, which is we can be grateful about. In terms of the setup, we saw a circulation pattern that caused the jet stream to deviate to the north through Canada, development of a high pressure system across the western US, clear skies, heat dome, persistent warmth. And because of the deflected circulation patterns, corresponding cooling in Canada. Returning now to this graphic from before, showing that widespread cool conditions across the Alaska and Canada, coupled with the warmth across the US. But thinking now about where we were setting records, monthly average records occurred across much of the western US and northern Mexico. Monthly record lows only really occurred on the border region between Alaska and Canada. Whereas there were some other regions of near record low temperatures. The area that had actual record lows in Canada and Alaska was only about 5% as large as the area where we saw record highs. So even though there was, of course, offsetting cooling to heating, the degree to which the heat in America and the US was extraordinary was greater than the degree to which this cooling was unusual for Canada. Uh, in terms of impacts, this exacerbated the existing drought across the western US, brought snowpack records levels to record lows for this time of year, likely to impact summer fire season and the water availability for agriculture and other uses in coming months. It could have been much worse for health if we had seen a heat wave this extreme occurring in summer rather than occurring in spring. But the ecological and water system impacts are still likely to be with us for a while. Uh, Now, I want to talk a little bit about what we see in terms of variability in the Western US. So this was an extremely large positive outlier in daily maximum temperature. We actually have the reverse only a few years ago, that we had an extremely cold March in the Western US. Uh, Not quite on the same way. It didn't really set, all-time records everywhere, but it was much more, high temperatures were much more muted. Uh, and so the highs were quite low in 2023. And as a result of this, what we now see, what seems to be the case is that March weather, at least in the Western US, may be becoming more variable, that the year-to-year variations in this part of the world may be getting larger swings. And that is troublesome from a climate perspective and from a forecasting perspective, because it means we are getting into much greater variability. It means we may be getting much greater variability than we're used to seeing. And that sets up the potential for these really anomalous records on both directions, anomalous record highs, but also very unseasonable record lows for this time of year in this location. I will note that the long-term trend is towards warming. There has been an increase of almost 5 degrees Fahrenheit since the mid 20th century in the daily Tmax for this region. But that variability is, if it is changing the way it seems to be suggesting, will really have a large impact on how we see the extremes in this region in the summer period, in the spring period. Okay, so I will say we now have a March temperature report available online. You can get to it through the link. Most of the discussion of temperatures in the US has gone out on our social media channels already, but is not, some of it is included in the March temperature report, but most of it is not at present. We may repackage some of the US coverage into a separate discussion at a later date to expand what we've already produced. Okay, and with that, I want to thank you for taking your time with me, and we will have open to some questions.